for vertical motion, which is classified as a uniformly accelerated rectilinear motion. This is one of those equations, and this is equation number 1. Now, your v there, the final velocity, will be the velocity at point B. And since this is vertical motion, then this is the y component of the motion, of the velocity. While its initial velocity is, of course, the y component also of the initial velocity. Remember, from the formula, v there refers to the final velocity. So that's the velocity at any final destination. While v sub o is the velocity, since this is a projectile, then this is from the initial velocity at the launching point. Now, since this is a vertical motion, then all of the two, must be the y components. No? The y component of the final velocity, the y component of the initial velocity. While our acceleration, since this is a UARM, is actually negative g. No? Wherein, for English system, this is 32.2 feet per square second. And as you can see, the time is also present in this equation, which is the same as the time under horizontal motion, because we are, our final destination is the same point B. Now, further substituting values, then that's going to be the equation for v sub oy. And let us refer back to the diagram for v sub oy. Alright, this is v sub oy. And if we are going to refer it to the diagram, this is v sub oy also, no? This particular side in here, which is opposite theta. So therefore, opposite means sine. Therefore, yeah, that's it. 800 times the sine of theta and minus g times the t. Now, in this case, there are 3 question marks up there. We don't know v sub y, we don't know theta, but anyway, that's our unknown, and we don't know time. So if you're going to consider this to be one of our equations, then we will have to add one more equation, because v sub y will become another unknown, no? Unlike in equation number 1, we only have t and theta, no? T and theta for the next equation. However, we will have the additional variable, which is v sub y. Now, if you're going to examine the next equation for you for kinematics, I mean. So our second equation of motion that is under kinematics is this, which involves displacement. But since this is vertical motion, then we must consider also the vertical displacement. While v sub o is the y component of initial velocity, and we have the common variable in time, and you have the presence also of acceleration, which is in this case the acceleration due to gravity, and of course the square of time, the same value of time. Now, simplifying it further to fit into our situation, because this is general, this is now specific, and we can see that there are only 2 variables that are involved in this case, because our vertical displacement is actually given in the problem, and that is 2000, while theta is our unknown and time is also unknown. So this function actually is just a function of time and t, t and theta I mean, which is the same as equation number 1. So therefore, if we will consider the 2, then 2 equations in 2 unknowns only, and we can now proceed with the solution of these 2 simultaneous equations in 2 unknowns. I'll just simplify the result, and that's equation number 2. Now, the summary. Alright, the summary of equations, we have again equation number 1 and then equation number 2. Now, since we cannot solve, actually it can be, it can be done, but it is really, challenging to solve t in terms of theta. So this is when my method, the method I am developing is not actually advisable, no? But instead, we will use substitution. We will substitute equation 1 to equation number 2 so that we will have an equation, the resulting equation is an equation in only one unknown, which is theta. That will be the content of our video number 3. Alright, that's it. Thank you.